Hello, all my wonderful people. I hope we're doing good today. Today's lesson is 2-3, and it's all about parallel lines, but also the triangle angle sum theorem, which is something that you guys already know, which is really exciting. You probably just didn't know what it was called. Okay, so hopefully nothing too terrible today. So let's just go ahead and get into it and see how it goes, okay? So our objective for today is by the end of this lesson, I will solve problems using the measures of interior and exterior angles of triangles. So angles that are on the inside of triangles, right, interior, and angles that are on the outside of the triangles, so exterior, okay? So we have a couple new vocabulary right now. We're going to talk about exterior angles and then remote interior angles, which is a special type of interior angle. And then we have three theorems, theorem 2-10. We have the triangle angle sum theorem, and then the triangle exterior angle theorem. So we're going to go ahead and we're going to jump to the last page, or the last, second to last page in our packet, so that we can go ahead and talk about what is an interior angle, what is an exterior angle, and what is a remote interior angle. So flip to that page of your packet and we'll get started. All right, so here we're at the terms page. So if I scroll down, I want to find where it says exterior angle. Oops, sorry. I'm in a real hard time here. Okay, exterior angle. So an exterior angle is an angle that's outside of a polygon. So it can be any shape. It doesn't have to be a triangle. Specifically, in this lesson, we're going to look at triangles, but just know that it works for all shapes. So that's why we said polygon. And all you have to do is extend the side of the polygon outwards. So let's just look at a triangle since that's what we're going to be looking at. Okay. So if I extend the sides of a triangle out, and out, like this, these are my exterior angles. So there's one, and there's one, okay? So those are my exterior angles. So they're created outside of the shape by extending the side of the shape. Something that very special happens for remote interior angle. That, again, I'm going to use a triangle as an example, but it works for other shapes as well. These are angles that don't share a vertex or corner of a triangle with the exterior angle. So if this is my exterior angle, right, exterior, then my remote interior angles are this angle and this angle, because they don't share the vertex with the exterior angle. So these would be my two remote interior angles. So that's going to come up quite a bit. So we want to just make sure that we have a good understanding of what that means, okay? The only other thing that's not on here is just a regular interior angle. So if you want, we can add this in here. So these empty squares are for, right? Interior angle. So an interior angle are just all of, I guess that's not the side to write on, huh? An interior angle is an angle created by two adjacent, so two sides next to each other, two adjacent sides of a polygon. So in not so many words, it's an angle inside of a polygon, okay? So again, if I have a triangle, all of these are my interior angles. X, X, X. Those are all, and I actually, let's get rid of the X's, it just makes it too much. Just do, all three of these angles are interior angles. Okay, so Not to be confused with remote interior, because remote interior means that there's an exterior angle as well. Okay. Okay, so let's look at some of our theorems. So let's scroll down into our postulates, theorems, and formulas. And we're looking for theorem 2-10. Here we are. And this is kind of a silly theorem, but that's okay. We're going to do it. Okay, so this says, and there's going to be a lot of writing. I apologize. So write small, okay? If there is a line, and a point not on the line, then there is exactly one line through the point, that is parallel to the given line. Okay, we got some music in the background here. Let me shut the door. Okay, so I know that this is a lot of writing, right? There's a line and a point not on the line, blah, blah, blah. But let's break it down in a diagram real quick, just to kind of make this, like, let's just break it down, okay? So if there's a line, so I'm just going to draw a line. Here's a line. Are we cool with that? There's a line, okay? And a point not on the line. Here's a point. I'm going to call it point P, okay? Then there is exactly one line through this point that is parallel to this line. So that means I can only draw one line that goes through point P that is also parallel to this line. Right? I can't draw it like this because that's not parallel. Okay, so hopefully that makes sense. Just reach out if I missed something. That phone call got me sidetracked. Sorry. I'm going to have to erase this so I can write in the triangle angle sum theorem. Okay, so let's scroll down. Okay, so the triangle angle sum theorem just says the sum, so that means adding, right? The sum of the measures of the interior angles of a triangle is 180. So all that's saying is the three angles of a triangle add up to 180. So if I have any randomly drawn triangle, this is angle 1, angle 2, and angle 3. Let's just say all this means is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 all equals 180. So again, that's something that you guys already know. You probably just didn't know what it was called. Okay, so it's called the triangle angle sum theorem. So if I add up all three angles of a triangle, I get 180 degrees. And again, I'm going to have to clear this out so I can write in the triangle exterior. Hopefully you guys are writing smaller than I am. Okay, the last one is the triangle exterior angle theorem. So we can say the measure of an exterior angle of a triangle, so we have to be specific here, of a triangle. So it doesn't work for all polygons, only triangles. is equal to the sum. So again, adding the sum of the measures of the remote interior angles. Hopefully you wrote smaller than I am, right? Okay, so the sum of, or the exterior angle is equal to the sum of the remote interior angles. So just as a reminder, so here's a triangle. If I extend one of those sides out, and let's call this angle 1. That is my exterior angle, right? Angle 1. The remote interior angles are the other angles inside that triangle that that do not share the same vertex. Okay, so what this means is if I take the measure of angle 2 and I add it to the measure of angle 3, I'm going to equal the measure of angle 1. So if I add my two remote interior angles together, I get my exterior angle. Okay, so that's it for all of our theorems and terms and everything. So let's go back to section 2.2 and we can take notes. All right, so back to section 2.3. We're going to look at example 1 here. And this is just kind of a reminder. So it says, what appears to be the relationship between the angle measures of a triangle? So right here, angle 1 and angle 1 are the same, okay? So these two images are related to each other. Angle 2 and angle 2 are the same, and angle 3 and angle 3 are the same. So here, if I add up 3 plus 2 plus 1, do you see how they make a straight line? So these add to 180. Well, it's the same thing here in a triangle, right? They add to 180. So the relationship between the angle measures, of a triangle is that they add to 180. So we can just write that, right? They add to 180 degrees. Okay, so if I was given 2 of the angle measures in a triangle, could I find the third one? And hopefully the answer here that immediately comes to mind is yes, right? You can add the 2 given angles, add the 2 given angles together, and subtract from 180. So not too bad there, right? If I know 2 of the 3, I can just add them together and then subtract it from 180, and that'll tell me what the third angle is. So we are going to do one proof in this lesson. Don't worry, just one, right? We're going to prove the triangle angle sum theorem. So what the theorem we just talked about, where all 3 of the angles add to 180, we're going to prove it. And we're going to stick with a 2-column proof here. Okay, so again, my statements are on the left side, and my reasons are on the right. And maybe we'll draw, so I'm given triangle ABC. So I'm just going to draw something like this. A, B, C. Hopefully that's okay, right? Just draw. So that's what I'm given. So I'm given triangle ABC. I know it's a triangle because it has the triangle in front of it. And then my reason here is given. Okay, and I'm trying to prove that angle 1 plus angle 2 plus angle 3 is 180. So I'm going to call this angle 1. Let's call this angle 2. And this one angle 3. So I'm trying to prove that those added together is 180. So what I'm going to do is I'm going to continue these out, the base here, and then I'm going to draw that parallel line through a point up here as well. And I'm going to say that these two lines are parallel. Okay. So because these lines are parallel, if this is angle 1, okay, and I call this, let's call this angle 4, 1 and 4 are congruent. And I can go ahead and say that angle 1 is congruent to angle 4. And I know that because of alternate interior angles. So alternate interior angles, right? I know these lines are parallel. So angle 1 and angle 4 are congruent. Along that same line, if I take this one and this angle and call it 5, I can say that 2 and 5 are congruent. So angle 2 is congruent to angle 5 by the same reasoning. Alternate interior angles. Alternate interior angles. Right? 2 and 5 are on opposite sides of the transversal and inside the parallel lines. Okay, so now this is what I see right here. So I feel confident in saying that the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 equals 180. Right? Because this makes a straight line right here. So 4 plus 3 plus 5 is 180. And I'm allowed to say that because I can add angles from the angle addition postulate. I'm allowed to add angles. Angle addition postulate. Okay, well that's great. Woohoo, right? But angle 4 and angle 1 are the same. So instead of angle 4, can I write angle 1? Yeah, right? Measure angle 1 plus, I'm going to kind of shift the order around here. The measure angle 5 and angle 2 are the same. So can I write angle 2 instead of 5? Yeah. And then angle 3 is fine in there still. So all I did here is I substituted values in. Instead of angle 4, I wrote 1 because 4 and 1 are the same. And instead of 5, I wrote 2 because 2 and 5 are the same. And all I did was then use substitution, right? Instead of writing 4, I wrote 1. And instead of writing 5, I wrote 2. So I just used substitution. And this is what I was trying to prove. So I'm done. I was trying to prove that 1 plus 2 plus 3 equals 180. Okay, so the rest of the lesson now is just kind of practice. So let's look at how do we use the triangle angle sum theorem. Okay, and we're just going to start plugging things in a little bit here. So example 3 says, use the triangle angle sum theorem. What are the values of x and y? So x and y right here. So I'm just going to start plugging in things that I see. So the first thing that I see here is this triangle. Hopefully we see that triangle. I know that this angle is 32, and I know that this angle is 78. So 32 plus 78 plus x equals 180, right? If I add up all three of those angles, I get 180. Of course, I don't have my calculator out, right? That's would only be the smart thing to do. 32 plus 78 is 110, so 110 plus x equals 180 minus 110 minus 110, and I get x is equal to 70 degrees. Woohoo! So I found x. Let's get rid of this. Now I want to find y. Well, y, I see this right here. Y and 78 are a linear pair. So y plus 78 equals 180. I don't even have to use the triangle angle sum theorem. I'm just using supplementary angles. If I subtract 78, right, subtract 78, I get that y is equal to 102 degrees. And that's it. Okay, I want you to go ahead and try the next one. I'll scroll down here in a second. But go ahead and try the next one. And then when you are ready to check your work, go ahead and just hit play on the video. Okay, so again, I want to know what are the values of x and y, right? So I see automatically this triangle right here. And I know two of the three angles, right? So I know that 35 plus 96, plus x equals 180. So if I solve, 35 plus 96 is 101. Sorry. Definitely 131. I was like, that's not right. 131 plus x equals 180. I subtract 131 to both sides, I get that x is equal to 49 degrees. Okay, so there's my x. Now y is maybe a little bit trickier to find here, right? I know that this is 35, but I know nothing about the total angle or what this is. But what I can find is this angle right here, because that's 180 minus 96, right? These two angles add, not the 77, but these two angles add to 180. So 180 minus 96 is 84. So I know that this right here is 84. So now I have a triangle where 77 plus 84 plus y equals 180. So now that's something that I can add up. So 77 plus 84 is 161. So 161 plus y equals 180. Right? Subtract 161 to both sides, and I get y equals 19 degrees. So hopefully that makes sense, right? That was a little bit different, but the same idea. Let's go ahead and try this one. If you haven't tried this one on your own yet, hit pause on the video, try it, and then when you're ready, hit play. Oops. Okay, so let's look now at this one. What is the values of x and y? If you don't automatically see how to solve something, just start filling in information, okay? So here I see a triangle. So I know that that adds to 180. So 57 plus 59 plus x equals 180. Okay, so 57 plus 59 is 116 plus x equals 180. Subtract 116, and I get x is 64 degrees. Yeah. So x is 64. I'm getting blinded. Okay, so I know x is 64. Well, if this is 64, then that means this is also 64 because they are vertical angles, right? They are across from each other. And that's going to end up helping me solve for y, because now for y, I have 42 plus 64 plus y equals 180. Okay, so 42 plus 64 is 106. 6 plus y equals 180. Subtract 106 to both sides, and I get y is 74 degrees. And that's it. We're kind of cruising. So if you're having trouble with that or that's not making sense, reach out, let us know, let us help you. And if it is making sense, yay, woo, go you, okay? So let's look at example 4 now, which is all about the triangle exterior angle theorem. So it looks like we're going to do 2 together, and then you're going to have a try it on your own. Okay, so let's start with part A here, which says, what is the missing angle measure in the figure? So this is what I'm interested in right here. Well, the triangle exterior angle theorem says that if I add my 2 remote angles together, I get the exterior angle. Okay, so all this means then is 45 plus 75 equals the measure of angle 1. Okay, my 2 remote interior angles added together equals my exterior angle. So the measure of angle 1 is equal to 45 plus 75, which is 120 degrees. And that's it. Same thing here. Here's my exterior angle. These are my 2 remote interior angles. So this tells me that 51 plus the measure of angle 2 equals my exterior angle, which is 109. Okay, so my 2 remote interior angles added together gets me my exterior angle. So if I subtract 51, I get the measure of angle 2 is equal to, and 109 minus 51 is 58. I'm getting blinded real good today. Okay, so you guys have 2 try-it problems here. Find the value of x in both of those figures. So hit pause, on the video, and when you're ready to check your work, go ahead and hit play, and we'll go over it. Okay, so let's check our work and see how we did here. In part A, I'm given the 2 remote interior, and I want to know the exterior. So the 2 remote interiors added together gives me the exterior. So I get that x is equal to 111 degrees. 54 plus 57 is 111 degrees. And then for part B, I'm given that my 2 remote interiors, so x plus 49, equals my exterior. Subtract 49 to both sides. And then 104 minus 49 is 55 degrees. So x is 55 degrees. So hopefully that went good. If you messed up and you need to fix something, make sure you do that so you don't have incorrect notes, right, in your packet. We have one more example and a couple try-its left, and then we're done. So we're cruising here. Okay, so example 5 is, how do we apply this in a real world-like situation? And how do we take something that looks really complicated and break it down in a way that makes sense, okay? So let's go ahead and read this prompt first. Cheyenne built this display for her ornament collection. Each shelf is parallel to the base. She recalls only the angle measures shown in the diagram, so right here. So this is a blown up version of this, okay? Now she wants to build another one just like it. What are the measures of angle 1, angle 2, and angle 3? So I want angle 1. I want angle 2. And I want angle 3. So we're going to do this slowly. And again, just like what we did in lesson 2.2, where we take something that looks really complicated, but we only pull out pieces that are relevant to us. Okay, so hopefully that makes sense what I'm saying, okay? So the first thing that I kind of picked out is that the shelves are parallel. I'm going to draw the full base and this little shelf, okay? And I have a line coming down like this. So let's kind of clean this up a little bit so we can see. So all I did was draw this. Okay? This I know is 75. And this angle right here is 55 plus angle 1. So here's 55 plus angle 1. So those two angles together are the same as 75 because they are corresponding. So this tells me that 55 plus the measure of angle 1 equals 75. Right? This angle is 75, 55 plus 1, boom. Subtract 55 to the other side, and I get that the measure of angle 1 is 20 degrees. So I can fill that in. Measure of angle 1 is 20 degrees. So all I did here was I took all of these lines that look really complicated and I just simplified it down to only use angle 1. Okay, so then I'm going to erase this because I found angle 1. I don't need that anymore. And if I do, I can redraw it, right? So there's that. Let's get rid of this. And let's get rid of this. Okay, the next one is angle 2, which is right here. So again, I'm going to draw the shelf. I'm going to draw the base. No, they're parallel. And then angle 2 is created with this line that's coming through. And I know that this is angle 2. So all I did, let's get rid of that too. All I did was draw this. Oh, and things I'm missing, you can connect that. This is 55. This is 20. If I draw this line, which doesn't really help, but that's okay. So this is 20 in here. Okay, and I'm interested in what is angle 2. Well, angle 2 and 55 are alternate interior angles of each other. So maybe this line is not helping our cause a little bit, right? So there, maybe that gives us a little bit easier way of looking at it. The angle 2 and 55 are alternate interior angles of each other. So that means that they are the same measure. So angle 2 is also 55 degrees because they are alternate interior angles. Okay. So then the last thing we need to find is angle 3, which is this little guy right there. So what I'm going to do is I'm going to look at this really big triangle. I'm going to look here and here and here. Okay, because I'm given now the 3 angles. I see that this angle is 45, so 45 plus this angle is 45 plus this third angle. Well, this third angle is actually made up of 3 different parts, right? It's made up of 55, it's made up of angle 1, and it's made up of angle 3. But all 3 of these angles equals 180 because it's a triangle, and the 3 angles of a triangle add to 180. So this angle, and this angle all add to 180. And I'm just going to solve. So 45 plus 45 is 90. So I have 90 plus 55 plus, and the measure of angle 1 I already know is 20. So I can replace that with 20 plus angle 3 equals 180. If I subtract 90 to both sides, I get 55 plus 20 plus angle 3 equals, and then 180 minus 90 is 90. Well, 55 plus 20 is 75. So 75 plus angle 3 equals 90 minus 75 minus 75, and angle 3 equals, oops, sorry, I forgot the 3. Angle 3 equals 15 degrees. So that one just had a little bit more work involved. And could there have been other ways to find that? Sure, right? Who knows? Yes, absolutely. This is just the way that we did it. But if you did it a different way, totally cool. I'm going to leave this image up because the try it that I want you guys to do is asking you what is the measure of angle 4 and what is the measure of angle 5. And we can keep assuming that the angle measures 1, 2, and 3 that we already found are still true, are still valid, okay? So I want you to go ahead and hit pause on the video, and I want you to find the angle measure for 4 and the angle measure for 5, and then when you're ready to go over it, hit play and we'll talk about it. Okay, so hopefully you tried it. Even if you tried it and got it wrong, at least you tried it, and good job, and I'm proud of you. Okay, so I want to know what is the measure of angle 4, and I want to know what is the measure of angle 5. So those are the two that I'm looking for. Okay, the first thing that I see is this triangle. And I already know what 3 is, right? So if I draw this again, just to make it a little bit easier to see, I know that 3 is 15 because I just found it, right? And this is angle 4. I don't know what that is. And then this one is 45. So it should be pretty quick to find measure of angle 4, right? I just do 15 plus 45 plus angle 4 equals 180. And we should get the angle 4 is 120 degrees. So hopefully that feels good for you guys. And then for angle 5, the one that I automatically see is this triangle. So this tells me that 45 plus 55 plus angle 5 equals 180. And if I combine that and I subtract and everything, I should get that the measure of angle 5 is 80 degrees. Now, are those the only way to solve? No. Okay, if you saw it differently, awesome. But those are the answers that we're looking for here, okay? One last try it is right here. Just determine the value of y. Note that there is an x. You might have to find the value of x in order to find the value of y. So just keep that in mind. Go ahead and hit pause. Start filling in any angles that you can find and see if you can find what is the value of y. Okay, let's go through this one. It looks a little tricky, right? So the first thing that I see, I'm just going to start filling in angles that I can find. Well, looking at this triangle, I can easily find angle x, right? 180 minus 54 minus 23. So angle x is 103. Even though it's not asking me to find angle x, I still might have to find it, right? So I'm going to just label this 103. Okay, so if this is 103, then I can easily find this angle as well, because it's just 180 minus 103, which is 77. Now, when I look at this triangle, I see that we have an exterior angle and the two remote interior angles. So that tells me that 77 plus 36 equals y. And 77 plus 36 is 113. So I get 113 degrees equals y. And there you go. So even though it didn't ask you to find x, a lot of the times in these geometry problems, you're going to have to find more information than just what it's asking you to find. It didn't ask me to find the value of x. It didn't ask me to find the value of this angle, but I had to find those values in order to find y. The other option, can I show you another option here too? just in case you did it a different way, which would have been totally awesome, is if you just looked at this angle, or that triangle, right? Where this is 54, and this angle is 23 plus 36, which is 59. Okay, so that whole angle is 59, and you could have done it that way too. 54 plus 59 equals y, and I get 113 equals y. So you could have looked at it as one big triangle, or you could have broken this down into two smaller triangles. So a lot of these problems have multiple ways that you can solve it. Okay, that's it for 2-3. Please reach out. Let us know if you have any questions, if you need anything. Other than that, we'll see you when we do 2-4.